All right. I just took. Can you do me a favor, please, and be ready for the lesson? They are not here to play. All right. Among those questions, I gave you 3 of them. I think the first one was number 4. Am I right?
Yes.
Okay, so let's go over number 4 quickly. Okay, number 4. Okay, just give me a second. Okay, so we start with number 4. Why are you talking? Okay, that boy sitting at the back who asked me to be here, can you do me a favor, please? Avoid talking to her so that we can make progress. Okay, right, so we have got 3k cubed plus 27 q cubed. Right, this is a sum of 2 cubes. Okay, now when you want to factorize this, always check if there is a common factor. Check if there is a common factor. The first term here is 3k cubed. The coefficient 3 is not a perfect cube, which means before we do anything, we have to take out a common factor first. Okay? We take out a common factor, it will make things a little bit easier. Right? So if I take out a common factor, end up having 3 times k cubed plus 9 q cubed. Like that. But still, if you look at the question itself, I think there's got something wrong. Because 9 is not a perfect cube. Okay? 9 is not a perfect cube. The 27 is a perfect cube, but the 3 is not a perfect cube. So, to factorize that, it won't be possible. The only way is to factorize by taking out a what? A common factor. Is there anybody who was able to factorize by a sum of 2 cubes? I doubt so. You can't. Because though the k cubed is a perfect cube, the coefficient of q cubed, which is the 9, is not a perfect cube. So you have to stop here. Okay. Then what was the next question? Question 10. Okay, so for question 10, we have got 8m to the power of 6 plus n to the power of 9. Now, fortunately, here, the 8 is a perfect cube. The m to the power of 6 is a perfect cube. The n to the power of 9 is also a perfect cube. Therefore, we can factorize by a sum of 2 cubes. So I can write this as the cube root of 8, it's a 2. So I'll open my bracket, I'll put a 2 there. The cube root of m to the power of 6, okay, the cube root of m to the power of 6, we divide this 6 here by 3. Okay, so you get m squared. Okay, so m squared times m squared times m squared 3 times will give you m to the power of 6 plus the cube root of 9 to the power of, n to the power of 9, you divide the 9 by 3 and you get n cubed. And you close the bracket. So that's the binomial factor. Now we need to determine the trinomial. The trinomial, right? First thing, you have to square these two terms inside the brackets. So in fact, we have to multiply them rather. So you get 2m cubed. In fact, sorry, we need to square the first term. So that will be, if you square 2m squared, you get 4. If you square m squared, you get m to the power of 4. That's the first term. So you square the first term of the binomial factor. Then if there is a plus here, you put a what? Minus. Okay? Then to get the middle term, you multiply the first term and the second term. So that will give you 2m squared times n cubed. Then the last term of the trinomial, it will be equal to n cubed all squared. So that will give you plus n to the power of 6. Okay? Then you may need to check that the binomial factor can be factorized or not. It can be factorized because 2 is not a perfect cube. M squared is not a perfect cube. The trinomial cannot be factorized. So it means this will be the solution. Okay? You can't carry on any further from there. Okay, if you got that answer for number 10, correct, raise your hand. All right, thank you. Then number 12, am I right? Okay, number 12. It looks scary, but it's not that difficult. Based on what we have done so far, you should be able to do question 12. Everything we have done up to this point. So number 12, it's 1 minus x minus y cubed. X minus y cubed. Okay? The 1 is a perfect cube. The x minus y all cubed is also a perfect cube. But I know that the bracket here will cause unnecessary confusion. So introduce a new variable. Okay, I prefer to use k. So I'm going to say let k be equal to x minus y. Okay? It's always better when you've got a situation like that, you've got inside the bracket, you've got a binomial, introduce a new letter. Then when you do that, you end up getting y minus k cubed. And we know that when you factorize this, we'll get 1 minus k, okay? 1 minus k times 1, because 1 squared is 1. Okay, there's a minus there, you put a plus k squared. Okay? So, in terms of k, those two will be your factors. But our question is in terms of x and y. So, where there is k, we have to put x minus y. So, our final answer is going to be 1 minus, I'm going to put my x minus y, I'll put it inside brackets, like that. Later, I can remove that. Then, the second bracket will be 1 plus x minus y. Okay. Let me not put that in brackets. The k squared will be x minus y all squared when I close the bracket. Okay? Now, I can remove the square bracket, okay, if I want. Okay, here, I can write this as 1 minus x plus y, and put that. There, I can write it as, okay, in fact, the square bracket won't go away. So 1 plus x minus y plus x minus y, then I'll put the square bracket. Then I'm done. Okay, you can't simplify it further. You stop there. Remember, the trinomial cannot be factorized. Okay, this is a square, by the way. There is a 2 there. Remember that. Okay. Is there anybody who got this? Thank you. That's all. I think this will be my conclusion of sum and difference of two cubes. You should be able to answer any question on sum and difference of two cubes for now. There's no need to be scared. Okay, to be able to answer any question. Because I've discussed all the key things that you need for you to answer the different types of questions. Then we'll move with a question before I move on to algebraic fractions. Okay, if you don't have a question, then allow me to carry on. So let's move on to algebraic fractions. Right, now for you to simplify algebraic fractions, you have to know how to factorize first. You have to know how to factorize. Now by now you've done 5 techniques of factorization. Factorization by a common factor, factorization by grouping, difference of two squares, factorizing a trinomial, factorizing a sum and a difference of two cubes. Those are the 5 techniques. The first 4 you did them last year, right? The new one you just concluded it now. So let's start with this. Okay? Number 4, if you want to simplify that, you have to look at your numerator and your denominator and make a decision whether you can factorize or not. Okay? So the numerator of this problem here can be factorized by a common factor. Okay? So that will be a times a minus 4 all over a minus 4. So I factorized by a common factor, which is the first factorization technique. Okay? Then since the numerator that is a minus 4, part of the numerator, rather, or one of the factors of the numerator is equivalent to the denominator, those two cancel. They only cancel out based on division. Okay? They cancel out based on division. So the final answer is going to be equal to a. That will be your final answer. So if you did the question, then mark the way. The numerator, we have got a squared as the first term, minus 4a as the second term. Right? This is not, well, I don't want you to confuse a difference of 2 squares with this question. It's not a difference of 2 squares. 4a is not a perfect square. If it was 4a squared, then it would become a perfect square. It's only 4a. So don't try to factorize this by a difference of 2 squares. Okay? Of course, the coefficient, if you take the positive of the coefficient, it's a perfect square. But the variable of the letter is not a perfect square. So factorize by a common factor. The highest common factor of a squared and a is the one with the smallest exponent, which will be a. So take out the a. A squared divided by a gives you a. Minus 4a divided by a gives you minus 4. Then you look at what's common in the numerator and denominator. If there is division, there is no addition or subtraction, you can cancel those terms out. Okay, that's it. Then number 16. Number 16 is slightly more complex, or rather I would say it's more complex than number 4. So you have to go fraction by fraction, numerator by numerator, denominator by denominator, checking if they can be factorized first. So start with the first fraction. Do we have a common factor? What's the common factor? It's going to be 5b. So write 5b open bracket. You don't need to get confused how to get the first term in the factor which is inside the bracket. Divide the first term in by the common factor. You have a here. Then minus 15b divided by 5b, you get minus 3. So I factorize the numerator of the first fraction. Then the denominator of the same fraction, I need to also factorize it if it can be factorized. So I've got 4a and minus 12. The coefficient of a, that's 4, it's a factor of 12. So I can factorize it. So if I do that, I'll end up having 4 times a minus 3. Okay? Then I've got division there. Okay, the numerator of the second fraction is simplified. I can't factorize it. So it will be 6b squared all over a plus b, because that denominator is simplified. Okay, then always try to see if the divisional fraction can a factor in the numerator and in the denominator cancel out. Okay, so here we have got a scenario where this a minus 3 and that a minus 3 can cancel out. Okay? Yes, I can cancel those two. Those of division. Okay? If I cancel those two out, I'll end up having a simple fraction, which will be 5b over 4. Now, because of this division sign, okay, it will be better to convert it to a multiplication. Then you invert the second fraction. So we'll end up having times a plus b all over 6b squared. Like that. Then furthermore, you might need to also identify some letters or numbers that are common. Because we have got multiplication here, this b and one of these two b's are going to cancel out. Okay? So, my final answer is going to end up being 5 times a plus b, so I'll write it, 5 times a plus b over 4 times 6b. Remember I said the b squared means there are two b's. One of those two b's cancels out with the b at the top here because there is multiplication. You can only do that if there is multiplication. If there is division, addition, subtraction, never do that. Okay? So you end up getting 4 times 6, that will give you 24, 24b. Right? If you want, you can simplify that numerator and remove brackets. But if you leave it like this, is still fine. You write it as 5a plus 5b over 24b. That will be your final answer. Okay, can't simplify it any further. Any question? Okay, let's move on to the next one. Right, the next one, it has got a denominator or denominators that are a little bit more complex. Like as I said earlier, first thing you look at the numerator for each fraction, check if they can be factorized. So this question, the numerator of the first fraction is an integer, so you can't factorize it. The denominator is a difference of 2 squares, so it can be factorized. So my first step is to write 3 divided by p minus 2 times p plus 2 plus the second one, it will be 2 over p minus 2 all squared, like that. All right, here we are adding two fractions. Since we are adding, we have to determine the LCD. We have to find the lowest common denominator. Okay? So, generally in my case, I prefer to write it down. So I'm going to determine my LCD. Okay? I don't know how you were taught in the past, but this is how I do it. The first fraction, we have got p minus 2. Okay? In the first fraction, we've got p minus 2. In the second fraction, we've got p minus 2 all squared. Okay? Now, do you see that this p minus 2, it's a factor of that? Because it is a factor of this p minus 2 all squared, it means that our LCD must have p minus 2 all squared. Okay? Our LCD must have p minus. In actual fact, this is called a multiple of what? Of that p minus 2. So, that multiple becomes part of the LCD. Okay, the other thing as well. The acronym LCD, lowest common denominator, you can also call it lowest common multiple. Okay? Lowest common denominator, lowest common multiple. You can also interchange those two. But because we are dealing with that fraction, then we put this D instead of the M. If it was not a fraction, then we call it LCM. But because it's a fraction, it's LCD. The D for denominator. But the concept is the concept of multiples. Okay? So my denominator, I'm supposed to have that p minus 2. Then I've got this p plus 2. It's not here. in that denominator, which means I have to include it in the LCD because it's part of the denominator of the first fraction. So my LCD will be p plus 2 times p minus 2 all squared. I need questions before I carry on. I need questions before I carry on. Huh? How's what? Okay, let me give you some numbers. Then let me give you some numbers. Let me give you some numbers. Let me give you some numbers. All right, can I have your attention? If I were to give you a fraction like, say, 2 over 5 plus 14 over 35, okay? If I ask you to say, find the sum of those two fractions, what do? I want you to tell me. You make what? Why do you make it equal to 35? Why do you make that denominator which is a 5 and 35 for you to add the 2? Yes, Taylor? Because 35 is the lowest common multiple of 5 and 35. Okay? Alright, look here. Our two numbers are 5 and 35. What is the lowest common multiple of these two? It is the largest of the two. Okay, look here. When I hope you are aware that 35 is a multiple of itself. Okay? Fortunately, 5 is a factor of 35. But if you are asked to find a common multiple, which is as small as possible, of both of them, it's not the 5, it is the 35. Okay, it's impossible to convert 35 to 5, but it's possible to convert the 5 to the 35. That's not true. Okay, if you want me to do that, if you want me to do that, then I can, listen, I can give you another problem, which is a little bit more complex than this. Yes, I'm only trying to illustrate the concept of the LCM and relate that to the LCD. Okay? If I had written it like, say, 2 over 5 plus, say, 3 over 7, okay? Like that. How would you carry on? Okay, what is the name of the common denominator that you're trying to find? What is it called? Okay, why do you call it the lowest common denominator? It's because 35 is the smallest, okay, multiple, which is common to both 5 and 7. Between, say, 0 up to 35, there's only one number, such that both 5 and 7 are factors of that number. Okay? So let's not complicate this. If you want to convert or find the LCD, like this here, don't divide this 14 by 2 or by 7. As it is like this, you have to find what is called the LCM of 5 and 35. And that LCM is the largest of these two, which is the 35, because 35 is a multiple of 5, and 35 is a multiple of itself. So here, p minus 2 all squared is a multiple of p minus 2. It is also a multiple of itself. Okay? P minus 2 all squared is not a factor of p minus 2, but p minus 2 is a factor of p minus 2 all squared. Therefore, the one with the largest exponent among the two, that is p minus 2 all squared, becomes the LCM or the LCD. Okay, let's carry on. So that's how you get it. This p plus 2 here, you can treat it as if here there's a 1 here. So 1 times that p plus 2 will give you that p plus 2. You multiply those two, you get your LCD. Right, let's carry on. Now, once you find your LCD, it should become easier now. The first denominator, you need to make it equivalent to that LCD. So which term are you supposed to multiply with to make it equivalent to the LCD? It will be p minus 2. So I'm going to multiply the denominator by p minus 2. Then I'll also multiply the numerator by p minus 2. So that I'll get 3 times p minus 2. For now, I'm not going to write the denominator because I know that it's equal to the LCD after this multiplication. Then here, what term should I multiply the 2 with to get the LCD? Which term should I multiply the 2 with to get the LCD? Or rather, I would say, okay, which term should I multiply the denominator here with to get the LCD? P plus 2. So I'll do the same at the top. So that will be p plus 2. Then all this is under a common denominator. That is p plus 2 times p minus 2 all squared. Okay? Then you can simplify the denominator. You can't simplify, so you can simplify the numerator, but the denominator remains as it is. Then you get 3p minus 6 plus 2p plus 4. This is all over. Please, don't forget to write the denominator because it's part of the answer. Okay. This is addition of algebraic fractions. So the denominator must be kept. So you write p plus 2 times p minus 2 all squared. Now we can simplify this further. 3p plus 2p gives us 5p. Minus 6 plus 4 gives us negative 2 all over p plus 2 times p minus 2 all squared. And that will be your final answer. Okay? All right? So if you had a challenge with the question, I hope it's better now. All right, I need to carry on to the next one. Is there anyone who has got any questions before I carry on? All right. And number 27. Number 27, we have to look at each numerator, each denominator separately and see if we can factorize. So, here, if you look at the first numerator, that is x squared minus 2x plus 1, okay? That's a perfect square trinomial. Why is it a perfect square trinomial? Can someone tell us? Why is it a perfect square trinomial? Why is the numerator there a perfect square trinomial? Based on everything that I've told you so far with regard to perfect square trinomials, why is x squared minus 2x plus 1? Yes?
The first is not a third of the trinomial. Square root of 1 is 1.
Alright. The proper language was to say they are both perfect squares. Also because the first sign between the first two terms is a negative. The middle term, okay, it is 2 times the product of the first and the last term. Okay? If you forget about the minus. You understand what I'm saying? If you multiply the x by the 1, what do you get? What is x times 1? X times 2? Get 2x. Okay? If you forget about this negative here, the middle term will become what? 2x. Alright, let's carry on. So, I'm going to factorize that it will be x minus 1 all squared. Okay, remember, a perfect square trinomial has got the same factors when you factorize. Then, the denominator, you have got x minus 1 cubed minus. Now, that numerator of the second fraction, can it be factorized? Can it be factorized? It can't be factorized. Why? Why you can't factorize it? It cannot be factorized because the coefficient of this middle term here is not a 2, but it's a what? 1. Therefore, it's not a perfect square trinomial. The first term is a perfect square. The third term is a perfect square. But it's not a perfect square trinomial because the coefficient of the middle term is not a 2. It's a what? A 1. Okay? Then, the denominator is a difference of 2 cubes. Okay? When you have got a scenario like this where a trinomial will not be factorized, in most cases, the question will give you a difference or sum of 2 cubes. Okay? So you end up having x minus 1 times x squared plus x plus 1. Okay? So one of the factors of the denominator is equivalent to the numerator of the whole fraction. Then when you get here, you can cancel out some terms. So here we've got x minus 1 cubed, and here we've got x minus 1 all squared. So two of these cancel with both those two. We get that. So that you end up having 1 over x minus 1. Then the second fraction, this trinomial and that trinomial are going to cancel out. And then you'll be left with minus 1 over x minus 1. Okay? Now, carrying on from there. Do you see that the denominator is the same? Do you see that the denominator is the same? The numerators are also what? The same. Since the denominator is the same, means we can subtract the numerators. So 1 minus 1 gives us what? 0 divided by x minus 1 will give you 2. Then who got this? Alright. So that's how you would approach this one. It's a little bit more complex though. Alright, but you just have to know how to factorize. Okay? Can I carry on? Right, the last one. Right, this question has got 3 fractions. I hope you saw that. It has got 3 fractions. This 1 divided by a squared minus 4b squared, it's on its own because of that minus. I hope you saw that. Okay? So we have got 3 fractions. So when I simplify it, let me recalibrate my again. Okay, so here I'm going to try and factorize the denominator. Okay? The denominator there. So we have got 1 over a squared minus 4ab plus 4b squared. Can that trinomial be factorized?
Yes.
Can this trinomial be factorized?
Yes.
The answer is a what? A yes. What do you call that trinomial? It's a perfect square trinomial. It's a perfect square trinomial. Because the first term is a perfect square, the last term is a perfect square. If you multiply the product of the square root of the first term and the last term by 2, you will get the middle term. So, this becomes 1 over a to the a plus, actually minus, a minus 2b, all squared. Okay? That's where you start. Plus, the second fraction, okay, can the numerator be factorized? Yes. It's also a perfect what? Square. It's a perfect square trinomial, so it will be a plus b all squared. Okay, someone might be wondering, but how are they getting all? The clue behind the perfect square trinomial is first term is a perfect square, last term is a perfect square. Find the square root of the first term. So the square root of a squared is what? It's a. The square root of b squared is what? B. A times b will give you what? AB. Multiply AB by 2, you get the middle term. Okay? So that's how you can identify your perfect square trinomial. If you can't identify a perfect square trinomial, you might have issues with some of the questions. Okay? So this becomes divided by the denominator. It's a difference of 2 cubes. So it's going to be equal to a minus 2b times a squared plus 2ab plus 4b squared. Okay? I need to remove these letters here. I just put there. Okay? Then we have got this last fraction here. 1 divided by a squared, it's a difference of 2 squared. So we can have 1 divided by a minus 2b times a plus 2b. I don't have enough space, that's why I'm writing like that. Okay? Then you must check if some of the terms can cancel out. But because we have got addition here and subtraction, you have to find the LCD. Okay? You have to find the LCD. So if you look at it, we have got a minus 2b squared. We have a minus 2b. We have a minus 2b. So what's the lowest common multiple of a minus 2b all squared, a minus 2b and a minus 2b? It's a minus 2b all squared. So my LCD is going to have a minus 2b all squared. Then we have got this trinomial here. This trinomial is also going to be part of the LCD. Okay? The good thing is that that trinomial multiplied by one of these two will give us a difference of 2. Okay? So I can just multiply, I'll say times a squared plus 2ab plus b squared. I'm not done yet. I still have another term which is a plus 2b. So that a plus 2b must also be in the what? LCD. So this will be times a plus 2b. Okay? Alright? So that will be the product of those three is going to be the LCD. Okay? So, let me simplify now. This one here, okay, because we have got a minus 2b in the LCD, means I have to multiply this numerator by the trinomial and the a plus 2b. Do you agree with me or not? So, my next step will be to say that will be, I'll start by writing the a plus 2b times the a squared plus 2ab plus b squared. Like that. Okay? We are adding and subtracting those two fractions. We are not multiplying. So we have to determine the LCD. Then, so I'm done with the first part. The second one, I've got a minus 2b, but here there are two of them, which means I still have to multiply this denominator here by a minus what? 2b. So I'll multiply the numerator by a minus 2b. Are you following that? So this becomes plus a plus b all squared. Now I also, you also need to be aware that we don't have a plus 2b here. So when I multiply, I have to multiply by a product of a minus 2b and a plus 2b, which is actually a difference of what? 2 squares. But I'm going to write this as, allow me to write it as a difference of 2 squares. Okay, so I'll write it as a squared minus 4, it will be minus 4b squared. Okay, that's the product of a minus 2b and a plus 2b. Because a plus 2b is not part of this denominator. Okay, a minus 2b is part of it, but in the LCD there are two of them. Okay, are you getting it? Don't just rush to say no. All right, so I'm done with the first two. The last one, I've got a minus 2b times a plus 2b. What I don't have that's in the LCD is the trinomial and one of those a minus 2b's. So I have to multiply it by the trinomial and the a minus 2b. Fortunately, the a minus 2b times the trinomial will give me a difference of 2 cubes. All right. Okay. I think you are tired.